Hello everyone. So welcome to topic H3 and today we are doing application of fundamental principle. So in this part, the first thing that we are going to see is different types of arrangement. The first part is what is the major difference between linear and circular arrangement. So suppose there are 6 positions opened up and it's a linear arrangement. Any one person comes up at the beginning as the first person to occupy one of these places. He or she will have all 6 positions opened as a number of choice because all positions are unique position. Whoever comes next will have 5 choices. Whoever comes next will have 4 choices, and whoever comes will have 3 choices, and eventually whoever comes at the last will have whichever one last place left. He or she will have to sit at that one particular place. He or she will practically will have no choice at all. And if I ask you how many choices or in how many ways all these people can be arranged, so 6 into 5 into 4 into 3 into 2 into 1, all of us know already that it is 6 factorial. So if you are supposed to generalize this, which I have already spoken about, that in linear arrangement n entities can be arranged in n factorial ways. But if it is going to be a circular arrangement, and if whoever comes first, how many choices he or she has, don't get lost with the positions that 6 choices again. That is not really correct, because in linear arrangement the positions were unique positions because they had a very unique reference point. But here in circular arrangement there is no such case because there is no reference point available, and even though it looks like there are 6 choices available, actually all of them are the same choices. So ideally it is looking 6 choices, but the person just has any one choice because they all are identical, and this is a very critical and an important fundamental point. And that is why if you remember in logical reasoning, whenever we start with circular arrangement plotting of the diagram, as I keep on saying that the first person you can plot him or her anywhere, because then accordingly the rest other people will adjust themselves, so orientation will slightly change. So first person has just one choice, even though it looks like 6 different choices. Whoever comes second now can use the reference of the first person and then have 5 unique position, maybe immediate to the left or immediate to the right and so on. So now because of the first person, the other ones which are coming, they will have the unique identity, and hence now the second person has 5 choices. Similarly third will have 4 choice now because she can use both of their references, so all becomes the unique positions and so on. So whoever last comes again will have just one particular choice. So again, if I ask you in how many ways all these 6 people can be arranged in circular arrangement, you will realize the answer is 5 factorial. So to generalize this, in circular arrangements, n entities can arrange themselves in n minus 1 factorial. In linear arrangement, n entities can arrange in n factorial ways. In circular arrangements, n entities can arrange themselves in n minus 1 factorial ways. Very, very important, very, very critical. Okay. Arrangement of identical objects. Suppose we have 3 letters CAT and we are supposed to arrange them. Consider that as a linear arrangement. All our distinct letters can be done in 3 factorial ways. 3 factorial, everybody knows, 6 different ways. But if you have something like this IIM, where the I's are identical, 2 I's are identical, you know that it will be just 3 ways, because the remaining 3 ways will be just the repetition of those 3 scenarios, because we cannot distinguish between the 2 I's. But what if we say that the 2 I's are color coded, something like this, one is red eye, one is blue eye. Now you can uniquely identify whenever they will interchange their places, that you will be easily able to identify them based on the color coding. So that becomes a unique. So to sum up all of this, what we can say is we can come up with a unique generalized formula that in case of an identical objects, whenever the letters are repeated and all of that, the distinct number of arrangements can be given by a simple formula, which is total number of arrangements divided by similar arrangements. As in, whenever you have repeated letters which are identical, you can't distinguish between them. arrange first of all possibilities considering as if they are distinct. That is what total arrangement is, and then just divide by the similar number of arrangements. So in this question, IIM wala, consider all three as distinct. So you have 3 factorial total number of arrangements divided by the similar arrangement. Two i's are you identical. So two i's are identical, and hence their arrangements of 2 factorial we need to divide. So 3 factorial divided by 2 factorial, that is 6 divided by 2. You get the 3 ways the same answer. So here there were just 3 letters, so we could practically figure out each of the 3 possibilities by arranging them. But if it is going to be something bigger, you don't need to do that, and this is where this particular formula will help you, which is the distinct arrangements in case of identical objects. So that's the whole objective behind knowing this small concept.
8 boys A, B, C, D, E, F, G, and H have to be seated on 8 chairs kept in a circle. Find the number of ways in which they can be seated. So these are the all possible arrangements. So it is going to be 8 minus 1 factorial, that is equal to 7 factorial. Now there's a formula. So whenever some people are sitting in circular arrangement, so let's say there are 8 people sitting in circular arrangement, we will make use of the formula that is n minus 1 factorial. So it is going to be 8 minus 1, that is equal to 7 factorial. Moving to the next question. 8 boys A, B, C, D, E, F, G, H have to be seated on 8 chairs kept in a circle. Find the number of ways in which they can be seated such that C and D always sit together. Over here, there's a condition. C and D are always sitting together. So in such cases, we will assume the people sitting together as one entity. If we assume C and D as one entity, then how many total people will be sitting in the circular way, in a circular way? So it is going to be 7. Now we will make 7 people sit in a circular way. So in how many ways can they sit? For that, we'll make use of formula, which is n minus 1 factorial. The value of n is 7. So it is going to be 7 minus 1 factorial, which is 6. Now, 6 factorial is not the final answer because C and D can also sit interchangeably between them. Means we'll have to do into 2 to it. So 6 factorial into 2, that is option 3, is the final answer. Moving to the next question. Find the number of ways in which 4 boys, 3 girls sit around a circular table so that no 2 girls are together. So there are 4 boys and 3 girls. Also, no 2 girls must be together. What we'll do is we'll assume the places of girls now. Now the red circles are the places on which the girls can sit, and also they can follow the condition. Some boys can be together. So it is not, there is no restriction on boys' part. So what we'll do is we'll select the boys who sit together. So there are 2 boys who are going to sit together. So hence we can say that we'll select 2 boys who are sitting together. So it is going to be 4 seat 2. Now seat for the other 2 boys and arrangement of each of the pair of the boys. So it is going to be, they can sit interchangeably. So it is going to be into 2. Also into 2 because there are 2 pairs. One pair, for one pair we'll do first into 2, for second pair we'll do second into 2. Now let's make girls sit. So girls can sit in this way. So arrangement of girls is done, but girls can also sit. There are 3 girls, so they can sit in 3 factorial ways. So 4C2 into 2C, 4C2 into 2 into 2 into 3 factorial, that is 144 is the answer. There's one more way of solving this question. Make the boys sit on alternate chairs first. So let us make all the boys sit first. Now, the arrangement of boys will be 3 factorial because 4 boys seated in a circular way. So n minus 1. So 4 minus 1, that is 3. So 3 factorial. Now what we are going to do is we are going to choose 3 seats out of remaining 4 girls. So it is going to be 4C3. Now we also have to do the arrangement of girls, that is going to be into 3 factorial. So this is another way of solving such type of questions. Final answer is going to be 144. Next question says, 8 beads of different colors are used to form a necklace. In how many different ways can it be done? In case of garlands, beads, and necklaces, no two arrangements has same set of names. So the formula for such type of questions is always going to be n minus 1 factorial upon 2 ways. So clockwise and anti-clockwise arrangement are treated as the same in this case. So we don't have to calculate separately in each case. As there are 8 beads in a necklace, total arrangements are going to be 8 minus 1, that is 7 factorial upon 2. So 7 factorial upon 2 is the final answer. Moving to the next question. 8 boys A, B, C, D, E, F, G, H have to be seated on 8 chairs kept in circle. Find the number of ways in which they can be seated if these chairs are numbered from 1 to 8. Now, whenever we have numberings, we have to take it as the positions having a unique identity, because now we can specifically tell that which person is going to sit on which numbered chair. So, in such cases, we have to treat it like a linear arrangement. So, 8 people sitting in a row, that means in how many ways can we make them sit? So, n factorial ways. Over here, n is 8, hence it is going to be 8 factorial ways. So, option 3 is the answer. Moving to the next question. In how many different ways can you arrange the letter of the word Mississippi? Now, there's a particular way of solving this question. So what we'll do is, first we'll take different arrangement of 11 letters. So in how many different ways can we arrange these 11 letters? We can arrange them in 11 factorial ways. Now, we also have some common letters over here. So we'll take out all the similar arrangements. There are 4 I's repeated, so we'll take out 4 I's. That is, we'll take out the repeating part, so 4 factorial. 4 S's, so again 4 factorial, and 2 P's, so 2 factorial. So it is going to be 11 factorial upon 4 factorial into 4 factorial into 2 factorial. Hence option 1 is going to be the final answer. Moving to the next question. In how many ways can you rearrange the letters of the word abracadabra? Now we have to rearrange it. So what we are going to do is, first we will take arrangement of 11 letters, that is 11 factorial. Then we'll remove all the common letters. So A repeated 5 times, so 5 factorial. B repeated twice, so 2 factorial. R repeated twice, so 2 factorial. Now we have to rearrange. So this means we must not get the arrangement which is given in the question. So we have to remove that one possibility which is given in the question. Hence we'll simply do -1. Option 5 is the answer. Moving to the next question. A match between Netherlands and Spain has a final scoreline of 5-7. First sub question says, in how many different ways could the match have proceeded? Second sub question, in how many different ways could the match have proceeded if the half time score is 3-4? Now, there are two teams, Netherlands and Spain. Score is 5 of Netherlands and score is 7 of Spain. So let us assume that we have 5 N's and 7 S's. So according to our concept which we have done, we'll make use of the same concept over here. There are 12 letters, so 12 factorial upon 5 n's are repeated, so 5 factorial. 7 s's are repeated, so 7 factorial. So 12 factorial upon 5 factorial into 7 factorial is the final answer. Now we can also solve it in this way. So choosing 5 out of 12 goals scored in the match for Netherlands. So for Netherlands, it is going to be 12C5. So option 2 is the answer to the first sub question. Now in the first half, Netherlands scored 3, Spain scored 4. So we can take it as 7C3. In the second half, Netherlands will score 2, Spain will score 3. So we are going to take it as 5C2. Now it's and means multiplication. So 7C3 into 5C2 is the final answer. Moving to the next question. 6 speakers, PQRS, T, and U have to speak at a seminar, one after the other. In how many ways can they be arranged if P insists that he will speak after Q has spoken, and Q insists that he will speak only after R has spoken? Now, there's a condition over here. But do not assume that P speaks immediately after Q and Q speaks immediately after R, because it is not given in the question. And don't take it in this way. So we'll have to take the separate arrangements now. So first possibility, R over here, Q over here, P can sit anywhere. So there are 4 possibilities. Now next possibility is Q at the third place, and P can sit anywhere from 4 to 6. So 3 possibilities. Next, Q at the fourth place, P can sit anywhere from 5 to 6, so 2. And the last one, Q at fifth place, and P can only sit at sixth one. Now, addition of this is 10. So first, now we have to make arrangement of STU. So STU can be arranged in 3 factorial ways, so 10 into 3 factorial. Now, let us take R at the second place, and again follow the same logic. If Q is at third place, there will be 3 possibilities. If Q is at fourth place, there will be 2. Q is at fifth place, there will be 1. Addition is 6. STU STU's arrangement will be 3 factorial, so 6 into 3 factorial. Now let's take R at 3. If Q is at fourth place, there will be 2 possibilities. Q is at fifth place, there will be 1 possibility. Arrange STU into 3 factorial. Taking R at fourth place, there will only be 1 possibility. Also, we have to arrange STU, so 1 into 3 factorial. Adding these 4 things up, we'll get the answer as 20 into 3 factorial. That is 120 arrangement. So option 1 is the answer. Moving to the next question. Before that, over here, the total number of arrangements with restriction is equal to total number of arrangements without restriction into probability of restriction. So this is an important formula. Now, total number of arrangement of 6 people without restriction is going to be 6 factorial. Probability that P speaks after Q and Q speaks after R is basically probability sample space is equal to 3 factorial and 6, and favorable outcomes is equal to 1. So probability is going to be 1 by 6, because there's only one possibility of P speaks after Q and Q speaks after R. As there are 6 people, so it's 6. So 6 factorial into 1 by 6, that is also equal to 120. Moving to the next question. In how many different ways can you achieve a sum of 32 or more when you throw 9 unbiased dice? So over here, minimum sum on throwing 9 dice could be 9. That is, I'll get 1 on all. Maximum sum would be 54. I'll get 6 on all. Now, I can also say that probability of 9 is equal to probability of 54. So, in this way, I can thus form a pattern. Number of ways of getting 10 as sum is equal to 9 ways. Number of ways getting 53 is also 9 ways. So the pattern is probability of getting 9 is equal to of getting 54. Probability of getting 10 is equal to of getting 53. So we are getting pattern of different symmetric sums. So obviously it is the probability is going to be equal. So probability of 9 is equal to of 15. Probability of 10 is equal to that of 53. Now over here we can simply apply the formula, that is minimum sum plus maximum sum upon 2. Minimum is 9, maximum is 54 upon 2, that is 31.5. Now 31.5. This is just to get the breakthrough. Breakthrough as in the middle point. So middle point is 31.5, but we just have to take the integral values. We just have to take the integral values. So it is going to be 31 and 32. So probability of getting sum from 9 to 31 is equal to probability of getting sum from 32 to 54, and that is going to be 1 by 2 because it's a break even point. It's a break even point. So 9 to 31 and 32 to 54 is the middle point. It's a break even point. So obviously the probability is going to be 1 by 2 only. Now the total number of outcomes would be total number of outcomes into probability of getting sum of 32 or more. So 6 raised to 9 is the total number of outcomes. So total number of ways getting a sum of 32 or more is going to be 3 into 6 raised to 8. It's basically 6 raised to 9 into 1 by 2. So 3 into 6 raised to 8 is the answer. That is option 1. Thank you.